And the last session, we were talking about tracking and tracing from Hanyo. Hanyo is also one of the advanced leading technologies in the CSSD. They are the gold, platinum sponsor of the next WFHSS. Today, we are very, very happy to work with a wonderful company from Belgium, Ultrasonic. And Ultrasonic's topic today is the hidden secret of ultrasonic cleaning. For all of the colleagues who are working in the CSSD, they must have an ultrasonic cleaner. But today, I'm very, very happy to have our speaker, Miss Nancy Steenbakkers, CEO of Ultrasonic, with us to tell us more about Ultrasonic and how important this device is in the CSSD. Today's participants and registrants, they are mainly CSSD technicians. We have people from the theater, CSSD in charge, CSSD managers, sterilization technician. Thank you very much for all of you who have registered. And this is our 5th session. So after this session, we will be issuing the first attendance certificate. Please bear with us. We have more than 500 different people who have participated in various sessions or watched the YouTube videos after the calls. So give us some time and we will issue the attendance certificates as we go forward. And the people who have registered, they come from all over the world, the wonderful Saudi Arabia, South Africa, Sultanate of Oman, UAE, Rwanda, Egypt, Jordan. And we are very, very happy to have you here, as well as our friends from Yemen. So I will cut my speech short. Just to give you a few advisory, please make sure to remember that this call is recorded. That does not mean you should be shy. We want you to participate with your questions, raise your hand, or use the chat to ask a question. Please keep your mic on mute for the duration of the call and only turn on your camera if you're asking a question or if it's absolutely necessary in order to keep up with the bandwidth. The recording will be available later on our YouTube channel and we will send a follow-up email to everybody. So my name is Babak Nabadi. I'm the founder and managing director of B.I.G Consulting. I will be your moderator today. And I'm very, very pleased to also reintroduce Dr. Ahmed Baggashi, who is the president of Mena FHSS. I don't know if Dr. Ahmed has had the time to join us or if Mr. Ali will fit in today before we pass the baton to Nancy. Dr. Ahmed, are you on the call? Because I cannot see. Mr. Ali, are you on the call?
Yes.
To the opening?
Yes. What do you call Mr. Dr. Ahmed Bakashi? Today he apologized.
Yes.
And yes. So what you said, I'm going to
Excellent,
start.
because Dr. Ahmed, he had an emergency call. Yes, I
Yes.
understand. So, Mr. Ali, how is our
Yes.
beautiful Oman? And I hope you are in good health.
Well, beautiful man is missing you. Hope inshallah you are going to
Thank
visit
you.
us.
Thank you.
Inshallah.
I hope so too.
Okay.
Thank you, sir.
So
Please go ahead.
about okay. Good. So about ultrasonic cleaner, almost it is as the webinar say, it is a hidden information about it. It's almost a lot of information is not understood, and only just they know that it is a cleaning only, and they don't know the exact purpose of it. So I am hope that with this, and also we know that this ultrasonic machine, it's not only used in healthcare facility, it is also in industrial also they are using. And I hope inshallah with today with our webinar, Miss Nancy, that she is going to open the hidden information and give us a very wonderful lecture about it.
Thank you very much, Mr. Ali. We appreciate your support and your participation. The Oman team has always the flag up in terms of education. Thank you. So,
thank you very much.
I will not take any more time. I will, Ms. Nancy does not require any more introduction. As I mentioned to you, Ultrasonic is a Belgian company, and Nancy also is a resident of Dubai and the UAE. She is very, very active in educating the customer and providing the product and solution to the end users. Nancy, I will stop sharing my screen and you can start, please.
Okay, thank you very much, Babak, for this introduction. Yeah, so I'm now at the moment still in Germany because we had 3-day Congress, the National Congress for Germany. And I was presenting my devices over there, and you could not believe, but the Germans are really, really convinced that we cannot clean any surgical instrument, or it has to pass in an ultrasonic device. But of course, there are many, many differences between a tabletop ultrasonic and so on and so on. So I will try to introduce you.
Yeah.
Hello? Is there somebody?
Sorry, Nancy, I just muted the other person. Go ahead, please continue.
Oh, okay.
We can hear you
okay,
well.
Sorry.
Yes,
yeah,
we
no,
can
no.
hear you well.
Okay, so I will try to explain you the basics of ultrasonic devices, because ultrasonics is really, yeah, you have the basics and you have done also the advanced technology. So now today I will try to introduce you with the basics, okay? And of course, I'm here to help you. So if you have questions after that, or you say, no, I don't understand, I need some more explanation or more information, you're always welcome, okay? Through Babak or straight to me, I'm here to help you. So I'm trying to share my my screen.
Okay.
The only thing is I'm not so into Teams, so I'm trying to find my presentation.
Take your time.
In one moment, so I think is one.
Yes, yes, very good.
That's the one.
You just
Okay,
have to
great.
put it in the, you have to put it in the, yes, exactly, in the screen mode, yes.
Is it okay? Everybody can see it?
It is still in the presenter mode. Can you put it in the presentation mode, please?
Yes, I did.
Nothing
in the
is
presentation
changing
mode.
from my side
My screen
because we
is
can
full.
see.
It's full open now.
Then you have to switch your screen. Can you go on top corner and switch the screen, because we see the presentation and the slides at the same time.
Just looking now. More no.
In the top left corner, can you click on that screen with the person? What is the press?
A moment,
then,
I'm trying to find it. Zoom, no, Zoom.
No, I think you just have to press the other thing that says the spiel. Is that the
This
presentation mode?
Yeah. This is my presentation mode.
Okay, then we start with this. We can see your screen well. It doesn't matter. We can see the slide on the side as well, but it's okay.
Okay. Anyway.
Go ahead, please. Thank you.
Okay, so Babak, thank you for the introduction. Who am I? Actually, I was a nurse. I was working 20 years as a nurse in the operating theater. That moment I was married with a surgeon, and we were really, always busy in operating theater. And that moment I had always the confrontation that instruments were not clean enough. So they said, yeah, it's sterile, but you still could see actually the dirt, the cavities, in the little cavities in some instruments. It's very hard to clean it. So this is my experience. And after that, I became a manufacturer because I really wanted to solve that problem. And now we are the more and more having these questions and demands to clean instruments more precise. And I'm very happy that I got actually all these opportunities from you, from many hospitals, to explain, to give some education, what to do, how to solve the problem. So anyway, who is Ultrasonic? Actually, we're just a small family business. It's just me and my husband. He's an engineer and he's a good listener. Okay, so the moment that I told him that this is actually the problem in the hospitals, at the hospitals in the CSSD, then he was actually trying to find new solutions, new technology, and it took a while. But we at the end we really were finding actually some problem-solving systems. So this is actually a little movie of our company, and I hope you will enjoy it.
Welcome to Ultrasonic NV, a Belgium-based high-tech R&D manufacturing
Nancy,
company
we don't see the video.
specialized in forward-looking infection control
Nancy,
technologies.
Excuse me?
see the video.
Okay, then I go further. Maybe you can share it afterwards, Babak, after this training.
Okay,
Yeah,
no
because
problem.
I know in some countries the internet is more slow, and I'm very
Okay, no
sorry this is
problem.
not working now for you. Okay.
Okay, no problem.
Now, our company has a full focus on pre-treatment of surgical instruments and flexible endoscopes. So this is really a niche market, because at the end we have all kind of sinks in CSSD and in endoscopy, and at the end we have to count on the staff if the job is well done or not. And that's why we wanted to create something automated, and this is why Ultrasonic is having market more and more. We know also, because I'm an experienced person, we know how tough it is to work in CSSD every day from the morning till the evening, to have this full focus on how to clean the instruments. Sometimes you really get frustrated that you have a new kind of instrument, you have not any background how to clean it, and after all you have to find a way to have a better cleaning at the end. But it's really you really have you may never give up, because there are always solutions. This is what I wanted to tell you. Okay, so please stay happy in your job. Now, cleaning surgical instruments, it all starts with a sink. Okay, you have a very simple sink, just a square sink with no additives or not something special
Nancy,
to help you.
sorry, I'm interrupting you, Nancy.
Yeah.
The slides are not moving. We are still seeing the first slide.
I'm in my screen is maybe you can share the presentation, Babak, because with me everything works well.
Okay, can you hold on a second? Let me see if I can.
I stop sharing, huh? Okay.
Yes. Okay. Mm-hmm.
Welcome to Ultrasonic NV, a Belgium-based high-tech R&D. Welcome to Ultrasonic NV, a Belgium-based high-tech R&D manufacturing company specialized in forward-looking infection control technologies, producing innovative and unique medical devices which drastically improve patient safety. At the R&D room, all prototypes are designed from scratch. Each device has state-of-the-art design and has been fitted with the most advanced data software, so contemporary cleaning demands are met. Ever since its inception, Ultrasonic's core mission has been to eliminate all contamination risks, which are so ubiquitous in today's hospitals. Given the complex nature of medical instruments, thoroughly cleaning them without compromising them in any way requires fine engineering skills and craftsmanship. The Endo, for instance, is the only device worldwide which can pre-clean flexible endoscopes semi-automatically. The powerful MED ultrasonic device, on the other hand, comes with a fully automated process per kind of instrument, rendering existent ultrasonic devices insignificant. All this results into flawlessly cleaned instruments, which on top of that benefit from a prolonged operating life. Innovation is key. Therefore, Ultrasonic keeps improving its designs in order to meet today's cleaning needs. Thanks to a 360-degree technical service, including remote control, fast solutions are provided at all times, ensuring the cleaning processes are not postponed. Increasing patient safety and tackling contamination woes requires persistent action, not only in hospitals. Through the Patient Safety Academies, awareness is raised and education is given. This versatile space is also the perfect environment for e-learnings, webinars, and remote device trainings. At Ultrasonic, commitment means more than just a word. It is all about doing what you say. We endeavor to be modern, forward-thinking, and long-term oriented. It is the only way to keep moving forward. Ultrasonic, unmistakably revolutionary.
Thank you, Babak. Can you go for the next slide? So this is actually our devices, what we are producing in Belgium. We have now also the mini versions. So please go for the next slide. And this is what I told you before. We really want to make you happy during your job in the CSSD. So cleaning surgical instruments, it all starts with a sink, okay? You have smart sinks, you have semi-automatic sinks, but still you have to count on your education level and the commitment of your staff if the job will be done in a good way or not. Of course, everybody does do his efforts to clean as much as they can, but sometimes you're missing some tools, you're missing actually some important detergents, enzymatic detergents, more advanced technology to succeed that an instrument will be cleaned or not. So can you go for the next, please? Of course, as I told you, you have this sink, you have water, you have brushes. Brushes are not smart, so it's also up to you if an instrument can be cleaned in a good way or not. Some brushes are very, let's say, advanced, but at the end it's just a brush. So brushes are also have the name and the capacity also that they can damage the end instrument. So the life cycle of your instrument is a way shorter than what you have with ultrasonic cleaning. So please, next. And again, of course, sinks, brushes, water, and chemistry. Chemistry is also very important to know what you're doing. You have very cheap products, and the cheap products is actually, that means it's a detergent, I convince that, but the additives in the detergent is sometimes too weak to clean an instrument. So we really have to look after the safety data sheet if every component is there to succeed actually a good cleaning. In ultrasonic cleaning, when you have a weak working ultrasonic cleaning, what we see in the market is that you use enzymatic detergents in your ultrasonic device. And to be honest, you count that moment on your enzymes to succeed a good cleaning. But actually, that means also that your ultrasonic device is too weak. It's not good enough to clean the instruments by themselves. So with us, it's different. We use a disinfectant detergent in in our ultrasonic sink, because we saw that that kind of disinfectant was really supporting the cavitation bubbles, which is created by the wie sagt man das? Ja, mein Deutsch. This is created actually with the transducers, but I will explain you later what is a transducer. Okay, can you go for the next? So of course, if you're cleaning it in a sink and you get it out and it is ready actually to put it in the washer disinfector, if you have that, these automated reprocessors, you really have to ask yourself every time with every single instrument, is it really clean? Clean is in some countries different than in other countries. So the cleaning efficacy, let's say in Europe, they really want to be assured that all bacteria and viruses are killed. But in some other countries, cleaning is different because you don't have the right water quality, you don't have the right water temperature. So this is also always influencing actually your cleaning. So, but of course you need staff, and the staff needs several times a year some training to get the right knowledge. Of course, when they have the right knowledge, they will also be more motivated to do the job in a good way. And then, of course, if you have good, motivated staff and with some knowledge, maybe you can use them also, that they will transmit the education to their own colleagues. This is something which is really important, okay? But we understand also that cleaning is a huge stress factor in every sterile department, because you have the schedule of the patients and the examinations, you have the emergencies in between, you have the quantity of your instrument sets, if there are enough available or not. The stainless steel quality is also something that you have to count on, because when the stainless steel is not in a good quality, you have easily some corrosion and so on and so on. And then, of course, if you're cleaning your instruments in the sink with brushes, the life cycle of your instruments are way shorter, because you're damaging it without knowing even that you're damaging it, okay? So please go for the next. So if you go to industry, so of course in the south of Germany, you have many manufacturers who are really producing all kinds of medical instruments or medical machines and so on and so on. But if we look to Swarovski, for example, when you have the glass statues or the glass art, they have really a requirement. It has to be fingerprint free clean. So that means it's 0.01 micron clean. You have to imagine also when you have a medical, so you see it on the last line, medical needs to have this cleaning efficacy about 0.1 micron cleaning. But you also have to understand the instrument leaves with that cleaning efficacy the industry. The moment it's entering actually the hospital or the CSSD or the OT, it will never get actually that cleaning efficacy. Although we are working with patients, we are working actually with contaminations and sometimes also with heavy duty bacteria that we cannot kill anymore with antibiotics and so on. So you see actually in the industry, they're really they have the highest standards to have a good cleaning policy. Please go for the next. So some medical brands that are using all the time ultrasonic cleaning, because they don't use any washer disinfector, because the washer disinfector is not, it's reproducible, but it's always with shadows. You have spray shadows because you have spray arms, and ultrasonic cleaning is really cleaning everywhere. Every little part of the instrument gets actually a decent cleaning. So like Storz or Draeger or Synthes or Martin, it's all made actually in Germany, and they all use ultrasonic cleaning equipments, but very advanced. So what is ultrasonic doing? What was ultrasonic doing is we were looking what kind of technology they were using to clean those surgical instruments after production. And we took actually some parts of that to use it now in the CSSD, and this is why we have the most positive reactions from CSSDs and hospitals worldwide, that they say really it's unbelievable, but your ultrasonic device is way better as a result in a shorter time than we ever saw with other brands. Anyway, ultrasound waves, what is it? Actually, is just a sound. It's a sound, and when you put a sound in the water, then it will create actually some bubbles. Those bubbles, we call it actually cavitation. Okay, so this is the word that we always use in ultrasonic world is cavitation with high frequencies, low frequencies, but cavitation is the basic name. Then, of course, when you create all kind of bubbles in the water, and you will see it later with some pictures, the bubble will put himself in a vacuum, and when there is an implosion, and this implosion is really creating the cleaning of your instrument. So this is just a basic. The picture that you see on the right side is a design of a transducer who is really creating all kind of sounds. And of course, when this transducer is connected with the sink, and in the sink you have the water. So, and there you will find all the cavitation bubbles. You can even not see it with your eyes. You cannot see it with your bare eyes, all these cavitation bubbles. They are really, really very, very tiny, but so efficient to clean. So please, can you go for the next? Now here on the left side, you see a picture. You see a picture, really a picture of a transducer, and this transducer has metal parts. So a metal part, a stainless steel part above, a stainless steel part on the bottom, and in between you have the piezoelectric part. And this piezoelectric part is really the most important part of your transducer to create the right frequency of your cavitation bubble. So you will see it also later. With this transducer, it's connected with a generator, and the generator will send a sign, electrical sign, to those parts, the brown parts that you see, and then it will give a movement, and this movement will be transmitted in the water, and then you will really creating actually cavitation bubbles. I know this part is very difficult to understand, but this is really the basic. If you don't understand what is in a transducer, then you don't understand anything. So please try to understand that this is the most important part of your ultrasonic device. It's the transducer, which is normally glued on your sink, but we will see it later, okay? Please, next slide. Now, on the left side, you see a stainless steel sink, and on the bottom, there you can see the two transducers in just a small ultrasonic equipment. What I want to show here is actually the stainless steel quality has to be a very flexible stainless steel, that we are assured that the wave that the transducer is creating, that the wave is really transmitted 100% in the water. Otherwise, if your stainless steel is too stiff or too hard, you will minimize immediately with maybe 20 or 25% less cavitation in your water. So that's why your stainless steel may not have the IZ304 or whatever. It's actually a duplex stainless steel that you have to use, because the duplex stainless steel is more tough, and it's also very reliable when it's glued with the transducer, so you will not break down the stainless steel. Okay, next slide, please. Now, of course, we were not the founders of ultrasonic devices or ultrasonic, or in any way the cavitation bubble. So Professor Keller and Professor Mixis, and I even don't know where they were born, but I think it will be in UK or in Germany. I have to look after it, but this is something that I miss in information. So this Professor Keller and Professor Mixis, what did they find out? They say, hey, we have a cavitation bubble, and every single cavitation bubble has always the same transmission. So it's actually what you see above. It looks like a signature. So, but every cavitation bubble has always the same signature. So that means it grows, it collapses, and then you have the shock waves. So this little that you see in the signature, this is really the cleaning of your instrument. Under that signature, you will see actually a cavitation bubble cut in half, that you can see how it's built up, and you can really compare it with the signature above. It's a little bit more or less similar. Okay, so please, can you go for the next? So as I told you, Professor Keller and Professor Mixis, they had the signature, that's what you see actually on the left side above. But under there you can see some pictures about the cavitation bubble. And every 4 microseconds, a cavitation bubble will be transmitted, will be organized, formatted, and will be always in move. So it will be created first, a cavitation bubble, because of the sound what the transducer is actually creating, and then you see on the second picture they will put himself more and more in the vacuum situation. And when the third picture is when the cavitation bubble is really full on vacuum, 100% vacuumed, then you will have this implosion. So it's not an explosion, it's an implosion. And this implosion happens every 4 microseconds in your bath. One cavitation bubble has also the character that it has the 50,000 or 90,000 Celsius heat. That means if you are using your ultrasonic device, in the morning the water will be more cold than in the afternoon. So actually you have to look after the temperature in your ultrasonic device. When it's too hot, your proteins will be sticked on your instrument. So you really have to keep an eye on the heat of your ultrasonic device. Next, please. Hello. Can I have a next slide, Babak? Thank you. Another concern that I see in many hospitals is when I ask people what is the frequency of your ultrasonic device, I think I can count one finger on 10 introductions that most of the time people don't know what is actually their frequency, what they are creating with the device, although it's one of the most important information that you have to get when you want to decide to buy a good ultrasonic device. Now, the whole beginning and also what we see very often in the market is there is an ultrasonic device with one frequency, and most of the time it's 35 or 37 kilohertz. Okay, why is it for 35, 7 and 37 kilohertz very popular? Because you can clean nearly everything and it will be cleaned, okay? So if you have a tabletop or you have a bigger one, it will always have that kind of frequency. But what are we going to do in medical fields? Because we have eye surgery, we have microsurgical instruments, and we cannot clean it actually with that type of frequency, because that moment you will damage your instrument. The surgical instrument, the microsurgical instruments are very, very sensitive, as you know, and it's actually also very tough to clean it in a precise way. So that's why you really need a higher frequency, and starting from 80 kilohertz and above 80 kilohertz, then you really can, you will really create very, very small bubbles. And these small bubbles are so tiny, but very soft in cleaning. It looks like you clean with a very, very soft brush without damaging any instruments. And that's why today you have ultrasonic devices with many frequencies at the same time, or you can put it on a specific frequency. So this is also something that you have to understand. What is a frequency? So the lower your frequency is, the bigger your bubbles. So that's good for orthopedics and just all common instruments. The moment that you go for more sensitive instruments, eye surgery, microsurgical instruments, then you need a high frequency, okay? When we should use those two frequencies together, this is also very, very funny, because that time you really can minimize your time of your procedure. And it's something that people don't know and don't be aware about that. So we can play actually also with the time and the efficacy actually of the cleaning, because we are using different frequencies. Please to the next. So what we see here actually is in the middle is the same ultrasonic sink with the 2 transducers. And on the left side, we wanted to show actually when you're creating cavitation in your sink, you still have open gaps. So if you click on that, Babak, it should move a little bit. You see that? Okay. So here you can see actually with those 2 transducers, they're not actually creating everywhere the same cavitation bubbles. Now that means actually because those transducers are creating a standing wave, and a standing wave is always creating the same frequencies, the same cavitation in the same spot in your ultrasonic device. So if you go to the right, then you can see actually the movement of a standing wave. Yeah, that one. You see? So this is a standing wave, and it crosses actually always on the line of 0. And here on the right side, which is moving now, this is sweep. So there is a sweep technology in every ultrasonic device at the moment, but still it's not good enough to create actually a homogeneous cavitation field in your ultrasonic sink. That's why we hear sometimes that people say, yeah, we have to load the ultrasonic device in a specific way that we are assured that these instruments are really getting actually the cleaning. Okay, this is actually one of the matters that we see in the market. Next, please. Okay, now what you see here, this is in a bath. So we put actually one article on the top that when you put the movie on, you will see what is happening in this bath. You see actually the white streams, so the white lines that say this is cavitation. In between, you see all kind of bubbles or some sprinklers, but this sprinkle things is not cleaning at all. So please, can you put the movie on? Yeah. So here you can see actually it's coming from the left side to the right side or from the right side to the left side. It depends of your electricity. But this is how I want to show you that you find all the energy to clean in the middle of your ultrasonic device, not on the bottom, not above, not in the corners. And this is actually, you have to imagine this is just some transducers on the bottom who is creating actually those fields. So this is something that we wanted that we really were respecting, and we say, yeah, you know, when we know that means we have to create more energy, more frequencies, more adaptive things that we don't have that kind of situation anymore in the bath. Okay, so this is really the basics. That's what you have today if you're using ultrasonic devices. But anyway, this is actually that you have to understand. This is what's happening in your ultrasonic device. So please to the next. Okay, now, how is an ultrasonic cleaning device built up? You have the stainless steel sink, you have the transducers, what you see in the middle. These are the transducers who are creating the cavitation bubbles, and then you have a generator on the right side. So, and you have to understand also the more expensive ultrasonic devices, sometimes it happens they have 3, 4, even 6 generators in one ultrasonic device, just to create all kind of different frequencies, just to help you that you can consider and you can choose your program to clean a specific instrument in a specific way. Okay, this is just a basic. This is something that you know. Okay, if you should buy an ultrasonic device, please consider and check your transducers. What kind of transducer are they proposing with your ultrasonic device? It's one of the most important information that you have to get from your supplier. Okay, next, please. As I told you, so chemistry is very important. You have to respect some time, you have to respect some temperature, and you have to use a very good and a decent disinfectant or detergent, which is really helping to create this cavitation bubble, what you see on the left side under. This is really a picture of a cavitation bubble. Next, please. Now here, this is something smart and to check and to show you actually, when you just have a sink and you use 1% of concentration of detergent, And you will need actually 60 minutes to achieve the same results when you put 1% in your ultrasonic device, and then it only takes 15 minutes of cleaning. Now, if you put more additives, more detergent in percentage, then you will minimize the time in your manual sink, but also you will minimize the time of your ultrasonic device. So that means actually the concentration of chemistry is still very important. You cannot clean your instrument in an ultrasound as long as you're not using actually a decent detergent or a decent disinfectant. Next, please. Now here you can see actually all kinds of brands. On the left side, this is just, I think it's from China or something, just a plastic tabletop where you can clean your glasses or your jewelry. In the middle, it looks a little bit more industrial, but still you only have one frequency and no more funny things like that. And then you have Elma. Elma, they are based and produced in Germany, which is good, but not good enough. Elma is very known to clean all kind of jewelry, and their first market that they had was all the jewelry creators in the world. And those jewelry creators are really also using actually tabletops. But of course, it's a jewelry. There is no contaminants with the jewelry. It just has to be glitter and glamour, let's say. So this is good, but then that moment, hospitals are using the Elma, which is not bad, but you have to respect maybe a half an hour to have a very good result. And then on the right side, what I see in many, many hospitals in Middle East is the ultrasonic cleaner for rigid instruments or any kind of instrument. And right away after that, they put it in the hot dryer. Now, I can tell you, if I should propose that in a hospital in Europe or in any, let's say, hospital where there are more regulations and IFUs that they have to follow, is actually not allowed anymore, not at all even, that you are using an ultrasonic cleaner and right away after ultrasonic cleaning, you put it in the hot dryer and then consider it's safe to reuse it again. So you cannot do that. So please stop investing in that kind of material or machine, because it's not helping at all, okay? So you're really facing other problems. Next, please. Now, we have many discussions. How can we validate? How can we check if our ultrasonic cleaner is still working? You have these SonoCheck little bottles, but I can tell you these are not reliable at all. This SonoCheck is actually made when they are feeling some movement anywhere, or you shake it just in your hand, it will always change the color. So with SonoCheck, you cannot check if the frequency is okay, and so on and so on. You know, the most simple thing actually to work with, to clean, to check your ultrasonic device is to to make actually a little frame and then put an aluminum foil on it, and then put it in your ultrasonic device. Now here you can see this result is after 120 seconds, you see some holes and you see a lot of bubbles. Now, I can tell you, if you see that kind of result with your ultrasonic cleaner in your CSSD, this is not good enough to clean your surgical instruments. Or you have to respect maybe 3/4 of an hour to achieve a very good result of cleaning. Okay, I will show you later with our technology what you can find out, but it's way better than what you have here. So you really have to understand, aluminum foil, when you have some holes here and there, is not good enough to clean your surgical instruments. Okay, so please next. Now, these are our devices. We made it also by measurement, by requirement of the client, and so on. But we have, first of all, we have on the left side, we have a manual sink. And then we have an automated rinsing sink that you put all the trays in it and it goes down, the lid will close, and then you really have a rinsing that all the heavy dirt will be gone, so you don't have to do it manually. When that, after 3 minutes, it will come above again, then it goes to the right side to the ultrasonic cleaner device, And with this device, we have a frequency modulation from 1 kilohertz to 10 megahertz. And the hospital, they can choose their own programs. So we can add in this device, we can add 100 programs. But of course, when we are installing this device, it has a basic 8 programs, which you are using all the time. Now, our ultrasonic device can also clean hollow instruments because we can have an attachment with a specific tray. And we can also clean robotic instruments. And it's really, really very, very decent. And also we had to prove it in European hospitals with a laboratory report that this device is really doing what we are saying. Next, please. Now, the new innovation is with this device, as I told you, we have different frequencies and so on. But also when you have a really good working ultrasonic cleaner, then you also need less kind of detergents because you really can count on the productivity of your ultrasonic, okay? So that means also that you cannot put any cleaning agent just in an ultrasonic equipment because it's all about your cavitation bubbles. Your cavitation bubbles just need the support of your cleaning agent and nothing in and not otherwise. Now, of course, if you have a good ultrasonic device, you really can you can really minimize the cleaning cycle. You can minimize it to 3 minutes even. Okay. Now, the first thing that you have to do in the morning is to degas your cleaning sink. That means you fill it up with water. In water, there is always some oxygen, and it has to be degassed during a half an hour to be assured that there is no oxygen anymore in your water, because oxygen and cavitation are they don't like each other. Okay, they're really fighting to each other. You cannot we cannot change it even. So degassing first thing in the morning, degassing is one of the most important steps that you have to do. Now, our ultrasonic cleaner has actually the power regulation. We have 3,000 till 5,000 watt power. While when you go to Elma or you go to another brand, they have 500 watt, 800 watt. And you of course you can imagine immediately when you have less power, it takes more time to clean an instrument. Okay. So we were considering also to create a device that you can clean fast and very efficient all your instruments. And even when you have, most of the time it's on 80% of power, but you also can minimize the power regulation that you can really just clean one instrument. There are so many possibilities to use our device with and to create really a very, very decent cleaning efficacy. Okay, what you see on the bottom, you see this green line on the right side. You see the green line. This green line is actually a wave in your ultrasonic sink. This is a normal wave. Okay, but ours is creating the blue and the red that you see. Our ultrasonic device is creating all those waves. So that means we can really minimize the time, and we can really clean more precise than what you have today. The next, please. So this is our aluminum foil, where you can see actually the cavitation fields are really homogeneously distributed. You see the small bubbles, you see big bubbles, but if you keep it there for 120 seconds, it will be gone. I don't know. Normally there is a picture extra. Can you click on it? Yeah. Here you can see this is a frame with the aluminum foil in our ultrasonic device. And you see we were just putting that maybe 20 seconds and you have this result. So here you can really see that the cavitation bubbles are doing their job. Okay, it doesn't mean that that when aluminum foil is totally destroyed, that doesn't mean that it will damage your instrument, because instrument is in stainless steel and aluminum is aluminum. Okay, and it's just a foil. So this is really very, very let's say enjoyable to see what we are creating, what kind of technology and efficacy that we can prove. Can you click again on that, because I think there is, yeah. This is from another brand. Also the validation of their ultrasonic device, and you see in these stripes, let's say, here and there some little bubbles, but they were putting this kind of ultra aluminum foils, I think for more than 3 minutes in the ultrasonic device, and this is the result. So I should consider and advise to you, please get just an aluminum foil, put it in around the frame, and just time it. When you really need more than 30 seconds to have some bubbles, means your ultrasonic device is way too weak to clean your instruments. Okay, so this is just a little job, let's say, to try and to find out yourself if you have a good ultrasonic cleaner or not. Next, please. Now, this is not what we were finding out. This is actually scientific proof that even cavitation bubbles, they can kill molds, all kind of bacteria, all kind of viruses, cannot survive when you have a specific virus in your water, or you have a specific very aggressive bacteria in your water. The cavitation bubbles will always kill that kind of bacteria or virus. It cannot survive at all. And also, even when you have a yeast, on the right side, you see the electron photograph of a yeast cell. This is actually a mold. You see actually the cell when it's untreated, and then a little bit down there, you really see that the ultrasonic bubbles are really destroying the mold structure. So this is really one of the proofs that you are sure that your ultrasonic device is really killing all these aggressive stuff. Next, please. Now, as I told you, we have different frequencies, different power. Even we have 2,000 till or 3,000 till 5,000 watt. Then we can minimize the time. So you see here some results in 3 minutes from a very dirty instrument tray to a very clean instrument tray. People cannot believe that, but we have the more and more witnesses, the more and more people are using our device, and they really are now witnessing that our ultrasonic device is really something very, very special, that it can consider and can be used really to do the very tough and hard job to clean instruments. Next slide, please. Here you can see it actually more precise. So we have one very dirty instrument, and on the right side, you see actually that all the dirt is gone. And even from above, you see a little bit corrosion, but all the rest is really the cavities with this instrument. Everything is gone. So it's really so clean in 3 minutes. And if we should always consider and to have that kind of cleaning efficacy, and you put it then in the washer disinfector to disinfect your instruments, of course you can understand your disinfection cycle is way better than what you have today when you just clean your instrument in a sink. Next, please. Okay, so here you can see when it's open, we have 2 levels. And those 2 levels on the left side, this is actually the pre-rinsing sink. So you put all your heavy duty trays in that, like orthopedics and so on. It will go down and it will spray all the dirt away. And then from that stage, you go to the right side, and then you put your trays also on those 2 levels, and then you have the ultrasonic cleaning. We have also this specific tray to clean Da Vinci, or any other robotic instrument is possible. And we have also a special rack to connect actually with the lower lock, all kind of hollow instruments. Next, please. Yeah, this is actually, this was a report, no problem. The report actually just showed actually with the Da Vinci instrument. Unfortunately, I had to do that. I promised it to Babak that I should translate it in English, but on the bottom, you see actually the Restproteinbestimmungsschaft, this 10 micrograms. So on 10, you see the 10. Okay, this actually is the cleaning efficacy inside the instrument. So we have only 10 microgram, which is nearly nothing of protein rest in the instrument. This is unbelievable good. Even Da Vinci came to us and they say, wow, Nancy, we never had such a kind of device who could actually achieve that kind of goal. Next, please. So here you can, yeah, this is the device. So here you can see actually a part of the device where you have on the left side, you see even in the sink there are sprinklers, which is really cleaning and flushing and rinsing all the instruments. And then on the right side, you have this ultrasonic device. But we go more in detail. So when we go for the next slide. So this actually is the spray sink. And you see the bottom is in a V shape. The V shape makes actually a very, very common things because you don't have to clean all the time and put all to get all the dirt out of the bottom with your hands. This is all automated, okay? So when you have a heavy duty cleaning with all these sprayers, the lid is closing and it will all happen in the sink himself, okay? And the drain is big enough to drain all the dirt through the drain. Next, please. And then here you have the ultrasonic sink. When you go further, then you can see actually that we have a sink with transducers on 3 sides. We have 49 transducers on each ultrasonic device, okay? Every tube what we're using is in stainless steel. We don't do anything in plastics. We don't want to do anything cheaper because this is always giving troubles with maintenance and the durability actually of your ultrasonic sink. Can you go for the next slide? There you can see actually the picture more in detail. So the bottom has transducers, the short side has transducers, and the long side has transducers. So we are really creating a kind of 3-dimensional cleaning. So it's a triple site in irradiation, which actually really creates a very short time, a very efficient cleaning efficacy in a short time, of course. And what I wanted to tell more, yeah, in every corner, from the corner or even in the middle of the field or on the bottom, you will find everywhere the same cavitation fields. And this is really an innovation that we never could believe that it could help the CSSD in hospitals. So with this kind of technology, you never have any dead zones, you don't have any standing wave, and you don't have any spray shadow. So really every single instrument will be cleaned on every side, and even on the inside, in the inside of the instrument will be cleaned as it is, that you really can have it as a new instrument. Next, please. Yeah, this is the report. Of course, when you Google about the efficacy and the effects of cavitation on different microorganisms, this is what I told you. You know, there is no bacteria, no mold, no virus is resistant enough to survive any cavitation fields. So if you should Google that, effects of cavitation on different microorganisms, you will find a lot of reports. Next, please. So the conclusion is when we introduce ultrasound to liquids, microscopically small vacuum bubbles are produced due to the occurrence of traction and pressure gradients. These bubbles implode instantaneously. So every bubble which is creating will implode all the time, all the time, all the time. And that procedure is called cavitation. So never ever forget this name. Cavitation is the key, okay? And the cavitation plays a central role for the use of all kinds of frequency powers controlled by the generator or the generators if you have many. So we also wanted to show, we also can now convince and show also that ultrasonic cleaning is high effective and more effective and precise than cleaning in a sink with bristles. So also now with the German Congress that we had a standalone. We brought our device here that people could see, could feel, could understand what our devices does, and they were really really surprised that they never heard about that. But of course, any innovation is new and has to be proven. So now we have this kind of technology already more than 6 years in the market. And we have the more and more demands even from users or now using our device. When they have more quantity of instruments, they go for a next and for even for a second or a third device from our company. So this is really for us the proof that what we are saying is what we are doing. Next, please. So, of course, we also have references in Taiwan, in Canada, Thailand. Now we have it also already in, I have to see, in Oman is an endo device, but in Oman there will be a big project for this device. Where did we sold it? Here in Latvia, we sold it now. But anyway, we have many countries are using now this kind of technology. But I just wanted to show you why Taiwan, because Taiwan has the most stricted FDA in the world. So we even achieved the Taiwan FDA. And it's also when this machine should be broken or there is something wrong with the machine, we can enter from a distance for a remote service in that device. So the biomedical department in every hospital, they get the training from us and they know what to do when there should be something going wrong with the device. Now, we are very happy because as we are building this very, very in a good way with everything in stainless steel, we never have actually a breakdown of the device. So this is really a reliable device that you can use as an industrial equipment. Next, please. This is a testimonial movie of somebody who is using our device. She's speaking French, but it's subtitled in English.
Bon, tout d'abord, nous avons regroupé 2 sites de notre institution. Donc la première chose qui a changé, c'est la quantité d'appareils que nous avons. La deuxième chose, nous avons beaucoup plus de matériel à traiter actuellement et nous avons également une augmentation d'activité. Et la troisième chose, c'est l'ergonomie du travail. On a beaucoup travaillé sur ce point lors de la mise au point de la nouvelle stérilisation. Si j'avais pu avoir le choix, ce serait quand même Ultrasonic que nous aurions choisi, tout simplement pour la technologie innovante, pour la facilité d'utilisation, la qualité des finitions et aussi l'esthétique, le design qui est vraiment très beau. Oui. Alors, les avantages que je trouve, d'abord, c'est l'ergonomie du travail, c'est la facilité d'utilisation. On peut également choisir la longueur d'onde des ultrasons en fonction du matériel que nous traitons. La qualité des finitions sont aussi très importantes, la qualité du matériel aussi. Alors, les grands avantages, c'est la rapidité d'utilisation pour le cycle, c'est la qualité des finitions du matériel, c'est le fait de pouvoir choisir les longueurs d'onde en fonction du matériel que nous traitons, la qualité du nettoyage. Alors certainement, d'ailleurs il y a déjà plusieurs hôpitaux qui m'ont posé la question. Oui, je recommanderais vivement cette firme.
So you can go for the next. So with this slide, I would like to thank you for your attention. And of course, I'm pretty sure you have some questions. So please be welcome to ask your questions if you have some.
Yes, Nancy, we have a lot of questions. Thank you very much. It was very, very informative. It is my third or fourth time that I attend this presentation of yours. And every day I learn something. Don't forget, this is, I checked this Keller and Mystic, they're American, by the way, for your next meeting. So we have some questions. I think the first one is that Susanna is asking about certificate. We will send the certificates next week for those who attended. This was the 5th session. Don't worry about that. Ashwin is asking, we are using Clifton ultrasonic cleaner. Very good one. Okay, thank you, Ashwin. We are happy that you're happy. Make sure to use the test that Nancy was teaching you or mentioning to make sure that your ultrasonic machine is efficient. Maita is asking, how do we estimate the efficiency of ultrasonics? Is there a tester to check the efficiency and capacity of ultrasonic? This is for you, Nancy.
Yes, there is
Mr. Babak, hello?
Yes, Mr. Ali.
Yeah, just because I have some emergency things, I had to go out.
Yes,
so I had to leave. So you can continue on that one. And just I
okay.
would like to
Thank
thank,
you very much, boss.
yeah, I would like to thank Ms. Nancy about this very interested webinar, which is already, she already came previous with us in Oman in Royal Hospital, and I have met
Very
her
good.
several times. I'm really
Yeah.
interested with a lot of things she talk about it, and they'll be like I'll be discuss with her in, after like after this one, maybe next 2 days, about something
Okay.
about
Yes, please.
the specification of this ultrasonic machine. So thank you very much, and I'm sorry I couldn't. I'll not. I
No
cannot
problem,
complete
Mr. Ali.
due
We
to some
understand
emergency.
because we are already over
Okay.
the time, so we are just answering the
Okay.
question for
Okay.
the
Thank you very much again.
wonderful 60
Thank you,
participants
Ali.
that
I
are
will
still on the call.
I will keep in touch with you. Okay, no problem.
Okay.
Yeah.
Thank you very much.
Thank you very much.
So, yeah.
Thank you.
Okay, go ahead, Nancy, please, if you can respond to that question.
Yeah, so there is a test device made at the University of Stuttgart, and this is a professor. He has a kind of file, a cable, let's say, that you can hang in your ultrasonic device, and this is taking pictures of all the implosions. But this device is so expensive. You cannot find it actually in the material to buy as a test device. It's not possible. So the only test that we can really do is the aluminum foil. This is the most common and the more easy and the cheapest way. But nothing more than that. You can also maybe test your transducers, but even then you're never sure if it's heavy, if it can handle the heavy duty. It's just the specifications that you have to get.
Okay, very good. Maita is asking again, is there a special solution for cleaning ultrasonics?
How do you mean with a special solution?
Yeah, this one I don't understand. Maita, can you elaborate, please, about your question? What do you mean by cleaning ultrasonics? Okay, then we have more questions about certificate. We will email you the certificate, Miss Munir. Yes, okay. And then we have questions again about, okay, do you have FDA or CE? We have CE, I know, but we don't have FDA, correct?
No, we don't have. We have Saudi FDA, we have CE, and we have also the Taiwan FDA.
Yes, 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 yes. Thank you, Helmut. Thank you for attending. Okay, I think the rest, there is one more question probably. Anyone else has any other question? If you missed part of the webinar, it will be recorded and it will be online on our YouTube channel. We will send you the links. Bahati, do you have a question? Oscar?
Yes, I have a question.
Yes, please go ahead.
Yes, thank you, Nancy, for a very important and very good presentation. So my question is about how to afford this device. Is very nice, which can help us because I'm a Rwandan, so I don't know how we can have this device and the guarantee when we have that device, the guarantee with the company. Also the price, to know if we can be able to achieve the price of this device. Okay, yeah. Thank you. Yes.
Okay. Well, I have one answer on that. We just sold now for the third device in Kuwait. we were there with the Ministry of Health, and the Ministry of Health considered and decided that every single public hospital has to use this kind of device. That means actually they go for patient safety, okay? So the more convenient, the more precise you can clean your instruments, the better way that you can consider and to actually to give actually really the patient safety what every patient actually deserve.
Okay.
Oscar,
Yes.
we have your email and you have our email.
Yes, yes.
Please send me an email after the call. I will get in touch with you.
Yes.
We have competent companies in Rwanda that can support us with your requirement. You are calling from King Faisal Hospital. Which hospital you're calling us from? Sorry, please remind me.
Boniface?
Boniface. Okay,
Yes.
excellent.
Yeah.
Excellent. Okay, no problem.
Yes.
We will get in touch with you.
Yeah.
Karen and I will take care of that. No worries.
Okay, thank you.
Okay, thank you. The question of Maite, the clarification, Nancy, is how do I clean my ultrasonic tank? How do they clean the ultrasonic tank?
Well, actually, just of course in the evening, you empty the end ultrasonic tank, you get the trace out, you can really take them out very easy out. You take actually a kind of cloth, but of course you use the same disinfectant as what we are using actually to clean the surgical instruments. This is a very effective way. The safety data sheet says that actually it only needs actually 3 minutes of contact time. So your cleaning, your ultrasonic device can be cleaned in a very, very short way and easy.
Okay. We have Francesco is asking, what do you think about vacuum boiling technology instead of ultrasonic system?
I have no clue about that. I have no information and I never saw it actually in real life. So I cannot answer this question, unfortunately.
Okay. Okay, I think we have done good. Thank you again, everybody, for attending the call. 1 second, there is one more question, I think. Can we put rubber type of material in ultrasonic for cleaning?
Yes, you can,
Rubber.
but yes, you can, but you have to respect a lot of time because rubber is eating the cavitations. So it helps, it works, but very, very slow and very, weak, let's say.
So it takes longer.
Yes, much longer. Yeah.
Okay, so everybody, thank you very much. You will receive a follow-up email with the link to the video. If you have any question, just please drop us an email. Make sure you follow B.I.G Consulting on LinkedIn as well as Ultrasonic. Nancy always has very informative information that she shares on LinkedIn. And I have very, very good news for you. In 2 weeks, we will have Nancy back and she will talk about flexible endoscope pre-cleaning. That is also one of the very, very important topics in the industry and a painful topic for many. So make sure that you attend. We have one more question here. Can you please tell us about the modes of ultrasonic machine? Modes.
The modes. You mean
sure.
the program?
Yeah, maybe. I don't understand the question, to be honest.
Yeah, the modes is actually depending what kind of frequencies is provided in this ultrasonic device. So I cannot talk about any mode as long as I don't have more technical specifications.
Mm-hmm. Yeah. Okay. I think maybe the modes change by the shock waves or by the frequencies that you provide in the chamber. But as you said, we need more details to answer that question. Okay. Thank you, everyone. Again, we are very, very happy to continue with these educational webinars. We will see you back in 2 weeks. In 2 weeks, that will be our last session for this season, because after that, we are going to attend Global Health. We will be in Hong Kong for WFHSS. Then we have the New Year's holidays, and we will have the WHX in Dubai, where we are also participating in the New Arab Health. And I believe the season 2 we will start after Ramadan, and we'll start talking about robots and introducing robots to the CSST. Thank you very much, and see you soon.
Thank you, Babak. See you.
Thank
Bye-bye.
you, Nancy.
Bye.
Safe travel. We'll be in touch.
Thanks.
Great
Thank you.
presentation. I appreciate
Thank you
it.
very much. Thank you. Bye-bye.